question is it in descending order? And the answer is no, though I have to arrange it in descending order. So can anyone dictate the descending order for this binomial? Minus x cubed. Awesome. Was 1/27. So remember, first I identified correctly, then I put it in descending order. Now here's my next step. Step 3. Do these two terms, it's a binomial, I know that, so it has two terms. Do these two terms have anything in common? Nothing in common, correct. Does this binomial have a negative leading coefficient? Yes, I have to pull it out. So the two terms in the binomial do not have a common factor, but they do, the binomial has a negative leading coefficient. So I have to pull that out. What is left in parentheses? Very good. Okay, these were preliminary steps. This is what I like to say, clean it up. Arrange it so that it's easy. But we have to perform several steps. Okay, what again? Let me summarize. First, we identify it. Secondly, we put it in descending order. Thirdly, third step, greatest common factor, none. But there is a negative leading coefficient that I have to pull out. Only now I'm asking myself, is there a special product? For binomials, remember, the strategy for binomials is different than the strategy for trinomials and is different from the strategy for polynomials. So I'm at binomials. I have 4 different special products. On the front page of this handout, 4 different special products. This is what I ask myself now. Is this one of those 4 special products? So there are 2 special products with plus and 2 special products with minus. Yeah. I will look at one of those 2. And now I have 2 questions for myself. Are these 2 terms perfect squares? No. Are they perfect cubes? Yes, they are perfect cubes. So then what do you cube to get this? And what do you cube to get this? If they are perfect cubes, then I have to think of the difference of which special product? The difference of? If they're perfect cubes. Exactly, the difference of cubes. So what do I cube to get x cubed? Perfect. What do I cube to get 1/27? That's it. So I identify the fact that x cubed minus 1/27 is a difference of cubes. And now the final step, how on earth do I factor a difference of cubes? And we talked about the formula last time. It's a binomial times the trinomial. I have to copy the negative sign. I have to get the binomial ready, and the trinomial will follow. So binomial, trinomial. And these are not connected. Okay. I already have the binomial. Can anyone give us the binomial? We just identified it. Exactly. If we factor the difference, the binomial has to have the difference, and the trinomial has to have the sum in the middle. Very good. So it's x minus 1/3. Now the rest should not be that difficult if we remember the pattern. So I square this and put it here. I square this and put it here. And in the middle is the product of those 2. So can anyone give us the trinomial? Say it again.
X squared.
Perfect. X squared. Excellent. Then 1/3 x. It's x times 1/3 or 1/3 times x. And then the last term is always positive. That's why I didn't even discuss the sign. What is it? Yes, 1/9. Now, do you think that this indeed is this? Let's say I don't believe it. What will you do to show that it's true? How will I convince anyone? Let's say I go home and I want to convince somebody one of my neighbors, that this is this, how will you do it? They know nothing about algebra. How will you convince them that this is this? What will you do? How will you multiply binomial by the trinomial? What is the procedure? We just have to, exactly, x to these three, negative 1/3 to these three, then distribute negative 1. What will you get? For sure. 1 over 27 minus x cubed. You can always convince anyone by going back, distributing, combining like terms, eliminating the terms that are going to cancel each other out, distribute negative 1, and you'll get this for sure. So this is what we have to do for any type of polynomial. So remember the strategy. Can I borrow one of your handouts just 1 second so I can show it? I'll give it back to you in a second. I can also open it on the website. So I was given a polynomial to factor. Factor in polynomial. Is it in descending order? It wasn't. Greatest common factor? No. Negative leading coefficient? Yes. So I arrange in descending order. I make sure I factor out the greatest common factor. I make sure that I factor out the negative leading coefficient if that's the case. And then I have 3 different strategies. You cannot interchange anything here. You cannot swap or anything. So if it's a binomial, these two don't exist. This is what you have to do. If it's a trinomial, these two don't exist. And this is the strategy that you have to follow. If it's a polynomial, these two don't exist. You have to follow this. So this is a summary of everything that you will ever encounter in factoring. Okay, so is this clear? Are all steps understood? Okay, is there anything else that you encountered that you would like to go back to? Anything that you worked on? Anything else? Anything else you would like to ask? Did you have any difficulties with trinomials? Is that a yes? Is that a no? Are we? Yes, please, Ryan, go ahead. Yes. Yes. Again, for some reason I gave out the last handout. I don't have one. If you could read it back to me, I'm sorry.
y2 plus 121 minus 121.
Perfect. Okay, so also go back and refer back to the last page. Okay. And also, I was just in the process of logging in again here. And I can open the document up there. I have a copy, electronic copy. Okay, so my first step, I have to identify the type of polynomial. It's a polynomial, I'm asked to factor it. What type is it? Perfect. What is the next step? Good. Is it in descending order? No. So I have to rearrange it. Can anyone dictate the descending order? Yes? Very good. Very good. Thank you, Juan. Okay, now the next step is, I know it's a trinomial, meaning you cannot apply anything from binomials, you cannot apply anything from polynomials. It's the middle strategy, and you have to stick with it. Okay? It's the middle in that handout, in this scheme. Okay? So my next step and my next question to myself, if you look carefully, is in that the steps are very clear. You cannot skip a step and then come back to the previous step. They are exactly set in the same order that you have to use them in. Okay, so first thing was descending order. Yes, now, greatest common factor. No. Negative leading coefficient. No. So now I'm trying the next step, and the next step is 2 special products. Those that we have an agreement that we sign on the first day of classes. It's a special product that we talked about on the first day of classes. So what did we talk about? There was a binomial squared. How many terms do I get for a binomial squared? Never 2. We have an agreement and we signed it. 3 terms. A binomial squared is 3 terms, right? So, yes, a trinomial. The first term squared plus 2 times the first times the second plus the second term squared, or minus in the middle, right? Okay. So, without looking at this middle term, would you say that the first and the last are perfect squares? Because if you say no, the first and the last are not perfect squares, then these two special products, or I should say the one with a minus, is not applicable. If this is a perfect square and if this is a perfect square, then I may have a special product here, but I don't know yet. So the first and the last, are they perfect squares? Yes, this one is what squared? Perfect. And this one is what squared? Awesome. Stay with me. So I am going to write y minus 11 squared. But it comes with a big, you don't have to write that, but I'm making a point. It comes with a big question mark. Why is that? Because I only looked at the first and the last terms. I haven't checked anything here. If this is negative 7y, it's not going to work. If this is negative 1100y, it's not going to work. If this is negative 1500y, it's not going to work. What should I have in here for this to work? 2 times the first times the second. What is the middle term that this one has? Negative 2 times the first times the second. Negative 22y. This term, this binomial squared, has the middle term negative 22y. Does this one have negative 22y? So then I'm on the right track and I will say yes. I checked the middle term as well. These are my notes. I checked the middle term. I didn't just look at the first and the last. Because now, as a counterexample, let me say this. Do you think that y squared plus 7y plus 121 will equal will equal y plus 11 squared? Why not? When I square this, I get this. When I square this, I get this. How come that this is not true? Because when I expand this, what do I have as the middle term? Yes, plus, yeah, positive 22y, which is not here. So these cannot be the same. So this is how I address those special products for trinomials. One more time, I look at the first term, I look at the last term, I write my idea, but then I have to check it, because I don't know for sure. So this one is 2 times the first times the second. It has the middle term negative 22y. It happens that I have negative 22y here, so that is the correct factored form. Any questions on this? Any questions on this? Factoring is a very good skill to have in algebra. Very good. You can say, oh, can I find the solutions with the quadratic formula? Yes, you can. But this is going to take, 10 seconds, 15 seconds versus quadratic formula that will take you a minute and a half. And then have to go back and factor it using the quadratic formula. Good. Other problems, other questions, anything else? Anything else that you looked at? Anything else that you tried? Is this handout done? Do we have other questions about the handout? Can we consider factoring done? Did you have any other questions on anything from the factoring handout? Now, I would like to look at a couple of these problems because I would like you to work on these problems for Wednesday. So please choose from here. And this is the simplification by factoring handout. So I would like you to choose one or two problems from here. So what about these problems? No one asked about 6y squared minus y minus 1. And no one asked about 4x squared minus 4x minus 15. And I didn't see any questions. I didn't have any questions from these three different types of problems. So how are we doing on that? Okay, here, I just found my document. Of course, it was right here. All times. Got it. Okay. Yes, someone, Ryan asked about this. All the other ones are fine. I'm gonna check right now. I'm gonna go come around and see that you have all those done. So any questions on this? No one can see anything because I was on a different setting. So any questions on this? Are they all done? Is that a yes? Is that a no? Okay, then I'll verify in a minute. So what about these? So you already asked about part A. What about part B? Is part B done? So we don't know whether we've completed it or not. We have or we have not. Okay, so why don't you tell me? So I don't want to move on if there are questions. What about all these? Are these done? Okay, so when do you think we can complete this document? Because I would like to move on. Can you finish this for Wednesday then? Do you need any help with anything? I don't know how to proceed if you don't say either yes or no, or what should I do? Yes, please, Ryan.
Could you B under factoring a polynomial?
This one B here?
Yes.
Very good. Factoring a polynomial is always the easiest because there are no special products. I don't have to check anything else but descending order, greatest common factor, and negative leading coefficient. So always 4 terms are always the easiest. If it's factorable, of course, assuming that. So for part B, we have x squared plus 2x squared minus x minus 2. They are in descending order. This is a polynomial, not a binomial, and not a trinomial. And the only method for polynomials is grouping. Very good. So I will group the first two without looking at the other two. And what do I pull out? Very good. What is left in parentheses?
1 plus 2.
Oh, because I copied it incorrectly. Yes, that's why. Yeah, I'm sorry. Sorry about that. Sorry. So in parentheses we have, very good. What do I have to have coming out from the other two? Otherwise I cannot continue. I refuse to look. I have to write it first. What do I have to have coming from the other two so that I can proceed?
X minus 2.
If it's x minus 2, I will never be able to proceed. I will get stuck and I will conclude that it's a prime polynomial. It's not factorable. If I want to continue, there is only one specific expression that I have to have in parentheses. Otherwise, it's not going to work.
X plus 2x squared.
Say it again. In here. What do I have to have in here? See, if I put x minus 2, I will not be able to continue. I'm done. I will possibly conclude that it's not factorable. What do I have to have coming out in parentheses? What do you think?
X plus 2.
If it's not x plus 2, I will not be able to continue. This has to be the future common factor that I expect. If it's not there, I won't be able to continue. But I cannot fabricate it. I cannot say it's x plus 2. I have to make sure that what I put here as a factor and a sign match, right? So now I look. I need a sign and a factor. Yes? Minus? I just didn't hear. I'm not saying it's wrong. I just didn't hear what you said. You said minus?
That's it. That's correct.
Correct. But I will just emphasize that there is a 1 in there. That's true. Perfect. So now, what is the common factor of these two terms that will come out?
X plus 2.
Of course. What is left in parentheses? Something coming out from the first and something coming out from the second.
X squared minus 1.
Very good. However, I know that this is not completely factored. I go back to the binomial strategy, descending order, greatest common factor, no, negative leading coefficient, no, special product, yes. There are 4 special products for binomials. Which one is this? There are 2 with a difference. One is a difference of squares and one is a difference of cubes. Which one is it if one is applicable? Difference of squares. Perfect. Danielle, thank you. And how do I factor this? Very good. X plus 1, x minus 1. We had examples like this last time with factoring by grouping or definitely at least the difference of cubes or sum of cubes. You must redo the notes. If you don't redo the notes, you will always start from scratch. And we will not advance. You have to find the time to watch the videos and redo the problems we did in class as many times as you need. Otherwise, you will not go into progress. You need to lay one layer of brick, and then the next one, and then the next one, and then the next one, so we can get to the roof. Okay, next question here. Anything else from these problems? Anything else? Have you tried anything else? Okay, one more time. I have to move on. Anything else? Yes, please. Marcus? Which one? This one or this one?
Yeah. No, that.
H, the last one here?
Yeah.
Very good. So let's take a look at that's an equation. So, and that is 1/2 x squared plus 5x plus 25 halves equals 0. Never ever be afraid of equations with fractions. Why? Can anyone say why? We should never be afraid. Especially if it's an equation, because we can what? What can we do with fractions in an equation? We can always eliminate them by multiplying both sides, in this case by, that's it. So this is x squared plus 10x plus 25 equals 0. In case we want to factor this, because we know other methods as well, but let's say we want to factor. Okay, what is it? Quickly. Is it trinomial? Is it in descending order?
Yes.
Greatest common factor? No. Negative leading coefficient? No. My first thought is a special product. I always hope for a special product, because if it's a special product, I'm done. I don't have any difficulty here. So first I'm going to look at the first term. Is the first term a perfect square? Is the last term a perfect square? What is your assessment then? Hoping that this is true. Well, indeed. But this, when you expand it, has a middle term. What will the middle term here be? For x plus 5 squared, the middle term will be 10. And yes, do I have 10x here? So this is the perfect factored form. No questions there. Any quadratic equation has to have two solutions. It happens that sometimes they are the same. They're not distinct, we say. They are the same number. Well, it happens that in this case they are the same number. Which number is that? That's it. There are two factors of x plus 5, so that's the reason why. Any questions? Okay, so I would like to look at this handout, so we can put this aside for good. I would like you to choose a problem from here, because the other 6 you will have to work on. The answers are here, but not the steps in between. So please tell me, choose the problem you like. Yes, please, Marcus. Which number? Number 5. So we want to work on number 5. Ready? So let's copy number 5, which is 5. Quantity 2x minus 3 to the 4th power. X squared plus x plus 1 to the 4th. 2x plus 1 plus x squared plus x plus 1 to the 5th times 4 times 2x minus 3 to the 3rd and times 2. Very good. Good pick. Thank you. So we are asked to factor this, or I should say simplify better. Simplify by factoring. Okay. Now, my first question is how many terms we see here? Can anyone tell us how many terms we see? This is very important. Without identifying how many terms I have, like we did on all these, without identifying how many terms I have, where is it? Without identifying how many terms, I didn't know what strategy to apply. Correct? So that's my first step. First, I have to identify the number of terms, clean this up. All terms have to be cleaned up, right? And then I'll see what I need to do. Okay, so one more time, how many terms we have? What do we mean by terms? When we say terms, how many terms we have here? One quantity minus another quantity. Good. So let's go back here. How many terms we had here? One quantity plus another quantity minus another quantity. Good. How many terms we had here? One quantity plus a second one minus the third one minus the fourth one. Okay. Now let's try one more time. How many terms we have here?
Eight.
Ryan? One more time. Okay, so let's look again. Let's look here. Plus equals. One more time. How many terms we have? Indeed, we have two terms. This is the first term because it's one product. Till I encounter a singular plus or minus, I cannot count factors inside a term. So this is all one product, one term, and then plus, and this is all one product, one term, and then equal symbol. Are we in the clear? Perfect. Now let's look at the first one, and I see, oh, it's okay. Yeah, it's 5 in front, and some factor, another factor, another factor. That's good. Here I don't like it, because I see a factor, then a 4 in the middle, which is also a factor, and then some other piece, and then multiplied by 2. I want to see the second term like this one, with a number in front. So I'm going to multiply 4 by 2, and put an 8 in front, and rewrite the whole thing from scratch. So 5, 2x minus 3 to the 4th, x squared plus x plus 1 to the 4th, 2x plus 1. plus, can anyone dictate the second one?
8
Perfect.
x squared
Very good. Plus x. Very good. Awesome. And then 2x minus 3 cubed. Only now I am ready to identify whether these two terms have common factors. Is it one common factor? Is it two? Is it three? None? What do you think? How many common factors, if the two have common factors, how many common factors do they have? So first of all, I see 2x minus 3 that is present in both terms. So then 2x minus 3 must be a common factor. I need to talk about the power. I don't know the power just yet. Is there any other common factor?
x squared plus x plus 1.
Awesome. So x squared plus x plus 1 is another common factor. So I have to write it, and I will discuss the exponent, the power in a minute. Notice that I put a bracket. So what follows is a bracket and bracket. Okay. Let's first discuss the power for each of the common factors. 2x minus 3 to the fourth and 2x minus 3 to the third. Which is the common factor? What power, I should say, should the common factor have? Exactly. The smallest of the two. Very good. Let's analyze the power for the other factor. This one has a 4 and this one has a 5. Which power will have the common factor called x squared plus x plus 1? 4. Do we all agree with this? Are you with me, everyone? Yes? Yes? Okay, very good. So now, next step. From this first term, I pulled out this entire factor. This is out. 5 is still left inside because there is no 5 in front. And I took 3 out of 4 out. So 5 is left. One of these is left. This is completely gone. And then 2x plus 1 is still in there. So can anyone tell us what to write? I will need more room, so I'm going to delete for now the end of the bracket here. Because I need more room. I'm not going to be able to squeeze everything in there.
5 times
Yes?
2x minus 3.
Awesome.
Open
Yes,
brackets, 2x
yes.
plus 1.
Very good. And now I have to copy this symbol. Do you all agree with what is in there? Okay, plus. Now tell me what else I have to write.
8
Yes, 8 has to be in there. Perfect.
x squared plus x plus 1.
In parentheses, indeed. Very good.
This is gone.
That's it. This is it. There is nothing else. Very good. Is this clear? Okay. I will copy the first two factors. There is nothing we can do. But I have to simplify the inside. I will have to apply which method to multiply two binomials? Which method do I apply to multiply these two binomials? Well, how is it called? Forget about the name. How do I do it? Yes, indeed. Or FOIL, right? So 5 outside. Please multiply 2x by 2x.
4x squared.
Awesome. 2x by 1. Negative 3 by 2x.
Negative 6.
Awesome. And negative 3 by 1. Very good. And then plus, here I distribute 8. 8x squared plus 8x plus 8. And then the final step, I will distribute 5 and combine like terms, and I'm done. So factoring, understanding factoring is really a useful skill to have. So I copy the first factor. I copy the second factor. Nothing changes there. And now let's see if we can simplify in brackets. 5 times 4. Maybe I should write it one more time. So 20x squared, this is -4 minus 20x minus 15, right? So 2x minus 6x is -4x multiplied by 5. And then I have positive 8x squared plus 8x plus 8. So 2x minus 3 cubed, x squared plus x plus 1 to the 4th. And then we have 28x squared minus 12x and minus 7. So this is the final simplified form. As I said, I did not work on this document myself. This was a document created by the math department. So 2x minus 3 to the 3rd, x squared plus x plus 1 to the 4th power. So it will be easy for you to check. Follow all the steps. If there is any other problem, we can do it now. If not, we'll move on. So please work on all these problems for Wednesday. So we can put factoring aside and forget about it. Yes, Ryan, you had a question? Go ahead.
Just wanted to come to this.
Oh, yes, I'm sorry. Okay, anything else from this document? How would you work on the fractions? Will be exactly the same thing. Just after you factor, you will probably be able to simplify with the denominator. But you cannot start simplifying in a sum or difference. Remember that, right? So please be very careful with this. So this is due next Wednesday. And finish up the factoring document. Okay, so now let's look here for a moment and see if you have any questions from last time. So here we looked at rational equations. Any questions on rational equations? I think we did more than one, I think. If not, if you need more equations, let me know. Then we looked at radical equations. No, actually, this was complete the square still. Taking square roots. Then completing the square. Remember the procedure, the middle term divided by 2 squared, and that's what we add to both sides. Then we looked at the quadratic formula, and we applied it. And then we started other types of equations, like polynomial equations, radical equations, absolute value equations, and this is where we stopped with the absolute value equations. Is there anything that you worked on? Remember, do not fall behind with the homework in my math lab, because once you fall behind, it's going to be very difficult to catch up, and it's part of your grade. Okay? Any questions from me? Any questions? So if not, I'd like to go back and finish this one. So this is in 1.6, and we had absolute value equations. Okay, we had radical equations. Now, one other type of equation that I would like to show you is what is called using a substitution, or it's also called quadratic in form. So equations, quadratic in form. What does that mean? They're not quite, yes, please. Oh, sorry. Thank you. Sorry. Thank you, Brian. Okay, so what does this mean? Equations quadratic in form. They are not quadratic. They're anything else. But they can be replaced by a quadratic equation. And you could say, really, so now why would I want to change an equation into a quadratic equation? If it's not quadratic, why do you want me to change it into a quadratic? Because it's easier to solve. Not because I specifically wanted to change it into a quadratic equation, but it would be easier to solve. And here's an example, and I'm picking from your book. On page 185, page 186, let's look at problem 42, in which we have x to the 4th minus 13x squared plus 36 equals 0. Before you ask, we will not have test 1 unless I finish including 2.5. So I would have to postpone the test. I fell behind because there is so much to say in this class, and we're not there yet. Okay, so I'm looking at this polynomial, and this polynomial has degree Anyone? What is the degree of this polynomial?
4.
4. How many solutions do I have to have?
4.
4. Very good. Do I know how to factor this? Maybe, maybe not. Maybe, maybe not, because the factoring is normally done with second degree, with quadratic equations, in quadratic polynomials, I should say. So, but I noticed something. I'm looking at which one of these two has the lowest power. I know it's a silly question. Is the first term with a smaller power or the middle term with a smaller power? Yeah, right. The polynomial is in descending order, so this is smaller power. So I'm going to say, what if I let's say, give me a letter, not x, any letter you want. M, n, very good. So we want n to be x squared. If I let n to be x squared, so in other words, this becomes n. My question now to myself is, what is this? Because I cannot have x and n in the same equation. I will never solve for anything. So if x squared is n, then I'm hoping that this one is what? If it doesn't work, and if it's not that one, I can continue. Exactly. And it is. Because if you square x squared, you will get x to the 4th. So that's why this equation, although it's not quadratic, there is no quadratic equation with 4 solutions. There is no such thing. It's not quadratic. However, it's quadratic in form because it can be replaced by a quadratic equation. So what would be the new equation that we just created?
n squared minus 2n plus 36.
This I know how to factor in a blink. For this, with this, I don't have any difficulties. With x to the 4th, I could have had problems. I don't know how to factor x to the 4th. So we basically use the substitution. We substituted x squared with n. Why? To make it easier. Do we have to? No. If you can solve it using another method, please do. But this is an equation that is quadratic in form, and we use the substitution. What was the substitution? Little n replaced x squared. Then the new equation became n squared minus 13n plus 36 equals 0, which I know how to factor. How do I factor this? And you can say it's descending order. Oh, it's n minus 6 squared. However, n minus 6 squared will have the middle term what? Negative 12. But this is not negative 12. So it's not that special product. I wish it were, but it's not. So then how do I factor this? The product is 36. No one asked problems like that. The product that I need, of two numbers that I need, is 36, and the sum is negative 13. So product, is 36, and the sum of the same numbers is negative 13. Since the product is positive, I'm looking for two numbers with the same sign. But since their sum is negative, I know exactly what sign they must have. Yes, Marcus? Very good. So then we have two n's. And you can say, who cares about your n? No one. The solution still has to be in x. But n was a tool that helped us solve this equation. So then n is from here and from here. Perfect. But this is not done. This is our creation, our n. But now I have to go back and replace n by what am I replacing n with? So this is a new equation that I have to solve. Can anyone dictate the new equation that comes from here? Yes, x squared equals? Very good. What is the new equation from here now? Right. What did we say from the very beginning? How many solutions do I have to present? 4. I have to come up with 2 from the first one. I have to come up with 2 from the second one. Which method is the easiest to apply for x squared equals 4? Remember, this is quadratic, and we have 4 methods. We have factoring. We have taking square roots. If it's specifically in a certain format, complete the square, never, and quadratic formula. Which one is applicable here in a blink? Of course, because it's already set up. But if I forget something crucial, I'm not going to get two solutions. Exactly. So from here, I have x equals 2. If I forget the crucial, then I will only get one solution instead of two. Exactly, indeed. And voila, these are the 4 solutions. So this is the method of substitution, but only for specific type of problems, types of equations, because the polynomial was quadratic in form. If it's not quadratic in form, you cannot come up with this. Therefore, you will not be able to factor like this. Okay. So would you like to work on one other problem like this? Or another absolute value equation? Like this one. Very good. Okay, so I'm going to choose problem, let's say 50. It's a very important tool. However, the applications are limited. Why are they limited? Because if the equation is not quadratic in form, then you cannot, or the polynomial is not quadratic in form, the method is not applicable. So let's look at 50. 50, 50, where are you, 50? Okay. 2, x to 2/3 plus 7, x to 1/3 minus 15 equals 0. And now you will see why I wanted you to complete this handout before doing this. But this is another possibility for me to show you how to factor. So this is good as long as you present these 2 documents next Wednesday. Okay, so I'm looking at this polynomial. I shouldn't even say polynomial because polynomials cannot have degree 2/3 or power 2/3 and power 1/3. This is not even a polynomial. I'm hoping that I can change it into a quadratic polynomial or quadratic equation. I'm hoping. I don't know if it's possible. I will look again and say, okay, this x has power 2/3. This x has power 1/3. Is this in descending order, sort of? Is this bigger than this? Okay, so I'm focusing on the smaller one. And I will say, I'm hoping that I can denote this. I'm going to say give me another letter, any letter you want, not x. Which one?
P.
P. Perfect. Let's say that I have P that denotes what? X to 1/3 indeed. But now, if this piece is not exactly what, I can continue. So if that piece is not exactly what, that will be a problem. What do I need that piece to be? Careful. Okay, let's come back. Let's come back. Let's analyze this one. Because, of course, this is a little bit easier because the power is 2 and it's not 1/3, right? So we said that if I denote this by n, I'm hoping, because otherwise I can't use this method, I'm hoping that this is exactly what? Ah. So now let's come back. Ah. I am hoping that this is p squared because that's what the quadratic expression comes into play. If that piece is not p squared, I cannot use the method. I have to start from scratch with a different one, which I don't have for this problem anyway. So, but is it true? I cannot just tell you, hey, believe me, that is p squared. No, I cannot do that. I have to say, if I square x to 1/3, do I get x to 2/3? So if I square x to 1/3, do I get x to 2/3? Yes or no? Yes, because I multiply the exponents. 1/3, 1/3 times 2/1 is 2/3. So that's why when I square this piece, which is p, I get this piece, which is p squared. So the polynomial is quadratic in form. Now, can anyone dictate the new equation that we just created? Aha, I agree with that.
Plus 7
Yes?
p
Yes?
minus 15.
Awesome. So we were able to change the given equation into an equation that is quadratic